So looking at this particular example, our scale factor is smaller than 1. There it is, which makes it what? A reduction or an enlargement? Reduction. Because reductions happen when our scale factor is somewhere between 0 and 1. Some sort of smaller than 1 fraction. The process remains the same as what we did for the enlargement. From every vertex, we're going to connect it to our center of dilation, in this case the point S. But unlike the enlargement, we don't need to go past the vertex because I missed. Let me try again. We don't need to go past the vertex because this is going to get smaller. So if it's smaller, it's going to get closer to the center of dilation. It's not going to get further away. I'm going to do one vertex at a time. So here's ST. I'm going to find the distance between S and T, the length of line segment ST. Lining it up, it looks like the length of ST is 2.3 centimeters. So the length of line segment ST is 2.3 centimeters. I need to find now the length of line segment ST prime, because T prime is the location of T after you have completed the dilation. So we'll say T prime is the location of T under dilation, scale factor 1/2. We're going to find that by taking the distance of ST and multiplying it by our scale factor. ST was 2.3, that's what we had measured before, and the scale factor is 1/2. You can translate that 1/2 into a decimal if you'd like, and then go to your very favorite calculator app. I'm using the green arrow today, Mr. Oliver Queen himself. Let me turn down the brightness on this so that you can see it. Down brightness, there we go. And 2.3 times 0.5, I get 1.15 centimeters. So that is what the calculator app gave me. And so I'm going to take my ruler, set the 0 back up along my center of dilation, and mark out 1.15. Okay, so there's 1 centimeter. There's 0.1, and here's 0.2. 0.15 happens somewhere between there. So right about there is where I'm going to put it. I'm going to mark that point off, and there's T prime, the location of T under dilation, scale factor 1/2. Repeat for every vertex. Okay? So go ahead and repeat with me. I'm going to do the steps again. I'm going to do it a little faster than I did the first time so that you can see what we're doing. From center of dilation to vertex, I'm going to dilate C next. There's my guide. I need to find the distance between S and C. I'm measuring 4.1. You may measure something different, and that's okay. You go with what you've measured. I'm writing out how I'm going to calculate where C prime ends up. C prime ends up, according to my calculator, that far away from S, 2.05. So S is 0. I'm going to go 2 centimeters. And then 0.1 is here, so somewhere between 2 and 2.1 is going to be 2.05. Feeling okay? Is this construction all right? Yeah? All right. going to go ahead and dilate R. Going to measure R from the center of dilation. R is looking like it's 2.9. Which means SR prime is found by 2.9 times 1/2. According to my calculator, that's 1.45. So 1, 4, and 4.5, right about there. Again, I'm dilating the entire figure, not just the vertices, and so I need to connect the vertices with line segments in the same direction that they were connected in at the start.